Good afternoon, dear colleagues. My name is Irina and today I want to present to you the work conducted by Olga Vorobyova and our team on comparative morphology of the cnidosacs and related structures in nudibranch family Fionidae. First of all, what is a cnidosac? Nudibranch mollusks lack shell and thus they possess various alternative defensive strategies. Some of them sequester nematocytes or stinging cells from their cnidarian prey. Cnidarians of tissues are digested in stomach and digestive gland, and intact nematocytes are transported toward the top of digestive gland, the verticula. There, they are stored in a specific muscular structure called cnidosac. When a nudibranch is attacked by a predator, the nematocytes are extruded through its apical part, so-called cnidopore. While the main features of this process have been studied comprehensively for the last 50 years, little is known about the plasticity of fine morphological traits across different elite lineages. So our main goal was to study the diversity of cnidosac fine structure and ecological traits of the family Fionidae. In total, 12 species from 8 genera were studied, and methods included various microscopic techniques, in vivo observations, and phylogenetics methods. Fionid cnidosacs show a common general morphology. There is a single muscular sac per cerus. On these pictures from confocal microscope, you can see muscular sacs of different genera colored in red. Cnidosac form and the thickness of muscular layers differ across the Fionid lineages. However, we didn't find any correlation with mollusk size or phylogenetic position. Also, in different nudibranch species, we found different types of nematocytes, which wasn't very surprising as they feed on different hydrozoan species. On the other hand, in case of ultrastructure, we found that not only the type of nematocytes is different in different species, but their comparative amount and arrangement differ greatly across lineages. In some species, they are stored in large vacuoles and are found outside cells in cnidosac lumen. In other species, they occupied apical parts of cnidophages and oriented toward lumen, like here or here. In this case, we didn't observe the digestive vacuole surrounding nematocytes. In most species, only cnidophages containing obtained nematocytes are present in the cnidosac. However, in several species, like representatives of the genus Cotanella, we also found supportive cells and cells containing granular content in vacuoles. We also found several specific features that may be regarded as specific synapomorphisms of the family Fionidae. First of all cladibranch nudibranchs contain specific chitinous elements, so-called chitinospindos, in their epithelial cells. You can see them in white color. It is believed that they help them to protect the soft tissues from damage from stinging cells of the prey. In addition to chitinospindos found in epithelium, we detected these spindos in the hemosol. Their function is unknown, but it's very unlikely that they are used for defense, since hemosol doesn't contact to nematocytes at all. Also, we found here specific cells with high photosynthetic activity. Their precise function is also unknown, but among elite mollusks, only members of the family Fionidae contain them. Summarizing our results and comparing it with current views on phylogenetic relationships within the family Fionidae, we can see that members of the family have very different specialization on feeding objects. They also use different feeding modes, as rudder characters vary greatly across genera. We can conclude that cnidosacs are highly adaptive organs and their morphology correlates with ecological traits. Thank you very much for your attention.